Ladies and gentlemen, please be seated. Welcome to the second day of PyCon. Thank you. We always say time is money, but in Python, dealing with time and date is a big problem. It sometimes brings the problem you have never expected. Today, let's welcome Mario Corchero give us a talk. It's time for Datetime.
Good morning, everyone. My name is Mario Corchero. I work for Bloomberg. I'm a software developer, but mainly I'm in Spanish. And if you want to chat with me, I'll be happy to guide you through some really nice places to go in Spain. That's what I love to speak about. We all can also speak about time. And I'm giving this talk because I feel Datetime is this model in Python where you guess and check many times, everything seems to work, things break 6 months in the future. And I decided something like 3 months ago to go really full in depth on it, and I just wanted to save you that time and show you how complex is time and not to underestimate it. So we're going to go over a little bit of background of what are all the concepts about the datetime that we have to be aware of. And then we'll go through some stories that show some common issues and how can we evade them. We will close with some links and references, and then we'll have some time for questions. And if you don't have questions, which I like, we'll go through some extra secret material. So first of all, I don't know if you know the allegory of the cave from Pluto. It's like it has many things, many ideas that are really nice to learn about. Like just you should have a read. And I'm bringing it up because I felt that the datetime has the same concept. You know, when I was working with time, I was seeing these shades of leap second and like time zones changing hour and everything, but I didn't really understand what was going on behind me. So there is this point when you're working in Python with time where you realize about everything that's going on. It's like, wow, everything makes sense now. And the first thing is we work with time and we measure time, but how do you measure what you use to measure time? So we use the second, but we never stop and think like, what is a second, right? And I want to speak about the different time standards. And the key is you need to have a reference to be able to measure everything else. And we use the second, but we could use anything. You could use the time that it takes to fill a bucket with water, and then you will be able to measure what's a day in terms of bucket of waters, or the time it takes you to go from work to home, and then you can say, yeah, a day is just 20 times the time it takes to walk from home to work. So the first of the three standards we're going to see is UT1. UT1 goes simple. Okay, this is the processor of GMT. And what it does is say, we're going to define the second as a portion of the time that it takes to the Earth to do a full spin. This is great for civil time because, as you can imagine, it's the closest we can have to solar time. But because the Earth is affected by the gravitation of the moon and tides, this is not as good for situations where we have to be able to be really precise with times. And that's why in our search for this constant recurrent time, we found out that the way electrons oscillate in Celsius is the most constant thing that we can find in the universe. So we started to build atomic clocks using Celsius, which gave us TIE, which stands for International Atomic Time. This is the time standard that's usually used on, for example, whenever you need to do some computing with astronomical computations, like how long it takes to send a planet from a ship from one planet to another, and things like that. And just to understand how complex is the computing of the time, there is people in all those many slabs just counting the time. Okay, so you can see this is not a simple question. If you wonder why time is so important, you have to know as well that the meter is defined relative to the second. So, and if I know I'm in the States. There's many people who say like, yeah, like the metric system, blah, blah. We use the imperial system. Guess what? The imperial system is based on the metric system. So you are all living in a lie, okay? You are all already using the metric system, whether you like it or not. So just move to the metric system inch by inch, okay? So then, so we had UTC, which they say, okay, so UT1 is great for civil time. TI is really good for, for computers and really precise time computations. So let's just mix them up. So UTC just computes the time using atomic clocks. And to ensure that we don't drift from solar time and from UT1, it introduces leap second to ensure that we don't go over 0.9 seconds of deviation. That's why you have the leap seconds. Okay, this is the time on the tower. It's like, oh, great, that makes sense. If you wonder about the name, what does UTC stands for? Is Coordinated Universal Time. Why is not CUT? It was a fight between the French and the English. The English wanted to call it CUT, Coordinated Universal Time. The French wanted to call it le temps universel coordonné, pardon my French. And because they couldn't reach an agreement, it was UTC. So UTC also defines offsets, which allows you to speak on time relative to a position. So you can say 6 UTC with 5 hours ahead UTC. So that just means 11 UTC. This is important to be able to do time zones. A show of hands, how many people have gone to the lightning talk this morning? You saw the talk about time zones and DST? So, that made me extremely nervous when I was seeing the lightning, like, oh God, this guy is just destroying my whole talk. So I'm just going to run really quickly over it. Basically, governments now define the offsets of all the geographical locations that are in the country. They just define the standard time, and they do it using offsets. This is crazy complexity. You just don't want to do it manually, as we saw in the lightning talk. So just use some standard library, and I'll run through this slides. Next thing is daylight saving time. As time was not complex enough, we decided to introduce what's called the daylight saving time, which is we will move our clocks 1 hour forward in spring and then 1 hour backward in autumn. When you say it like that, it sounds simple, right? But this is only followed by some countries. Countries will do it at different times. So like, for example, New York will do it 1 week earlier than London, which is going to destroy all your meeting schedules. And guess what? Winter is different in the northern hemisphere than in the southern hemisphere. So it has been agreed that whatever this saves us money or costs us money because of the daily saving time is something around 1%. So it's totally not worth it. And some countries are actually moving out of it. The last concept I want to speak about before starting the common issues and how to avoid them is that you have to be careful when handling with time. You have to identify if you're working with timestamps or if you are working with well times. So the main difference is when we're working with timestamps, we're speaking of a point in time that is absolute for all the geographical locations of the Earth. So let's say, for example, when you log a line into a disk, or when a star is born, or when your hard drive goes kaput. Whilst well time is whenever you say, let's meet tomorrow at 3 o'clock on the lunchroom. So you can see that they are conceptually different, and this is going to affect how you have to write your code for it. So common issues and how to avoid them. I have a friend, he's Nacho, he's really nice. He works remotely, and all he has to do is after his long day, he just has to send the time that he left work to his boss, Mercedes. So this is how he's doing it. He's just using the datetime model, is getting now, which returns him at datetime, and then he's sending it to Mercedes. And then Mercedes receives this and says like, okay, so you left at 9:48, but is this in Madrid where you're based? Is this in London where the server is? Or is this in New York? Because you're really nice and you already converted it to me. Mercedes has no idea. So the issue is that a time within an offset, it gives you nothing. It's just a date and a time in a specific date. It doesn't give you an absolute point in time. And when I say absolute, I mean for the Earth. So all you have to do is just set the time zone, right? So whenever you create a datetime, don't do this thing like UTC now or anything like that. Just use now, pass the time zone inside, and just get the datetime with the time zone. So now when Nacho sends it to Mercedes, no more issues. Everything is clear. Mercedes can see the offset, and she knows what's the exact time that he left the office, and he can get his big check and play League of Legends after work. So, yeah. So then we have David, who he knows about all these problems with datetime. So we actually have 2 different clocks. He also works remotely. So he had one with Madrid, where he's based, and another one with New York, because he's an expert at datetime. And he has wrote a program that allows him to get metrics every hour of the different computers that he's monitoring. So all he's doing is he's writing into a file every single hour what are the metrics. So as you can see, he now has passed the time zone to whenever he does datetime now, and then he prints on its own crazy format the name of the file. Guess what? Surprise, surprise. There is one day that there is 1 hour missing. So what's going on? The problem is that some time zones can have 2 offsets. This is because of the DST change. So there is a point in the year, there is a day in the year where we will move our clocks 1 hour forward or 1 hour before, and this is going to screw up all your configuration if you're following that, for example, for this use case. What can we do? If we're working with timestamp, just use UTC. If you use UTC, your time is your time is going to be kind of monotonic and ascending. We can see that that doesn't always work because of NTP and other things, but you are much safer using this approach for this kind of use cases. So, second tip, if you really need to work with time zones and you're working with timestamps, just convert on the borders. Just do some kind of a sandwich for UTC. You convert on the border to UTC, and whenever you need to return it to a client, you store the time zone and then convert it back. No more issues for David. He's going to be totally successful. UTC for the win. So now he's logging like that, and he won't miss any more files. Then we have Melania. She's aware of all the issues that both David and Nacho had. And she's working on a company that automates the opening of a theme park on Turkey. And because he knows of all the issues, he just is converting everything to UTC and sending the UTC time that the gates have to open to the doors, so it's automatically. But there is one night that she gets called, and there is a guy yelling to her in Turkish. And it turns out that the kids had to wait 1 full hour to open, and the doors took 1 hour to open because Turkey decided to change the time standard, the offset to just don't follow any more DST. So because she mapped all those future wall times, because you see the problem is the time that the doors are going to open is a wall time, it's not a timestamp. And she mapped those wall times into a timestamp. And this is a problem because countries changes, but just by law, they can just change, for example, not to follow DST anymore. So tip, if you want to avoid this kind of issues, first of all, keep your time zone database updated. If you're using PyTC or PyTZ, as you say, I think, just keep that updated, the same for dateutil. If you're working in a big company, you probably are using a shared, like a file that is shared across all the languages. So you just, be sure that your system infrastructure is updating that. And second thing is don't resolve future wall times. If you are wondering what to use for the PyTZ or dateutil, until 3.6 it was recommended to use PyTZ by the Python documentation. Now it's dateutil. And we have here Paul, which is the main maintainer of dateutil. Paul, can you please stand up? How many people have used here dateutil? Can you please have a show of hands? How many times could you thank someone for their work? Paul is just working, I'm just a random guy that puts some presentation, but this guy is working daily on dateutil for all of us. So thank you, Paul. Let's keep with the presentation. So, well, Melania knows about all this. She knows it's really tricky and no more issues, right? Well, those many changes happened last year. This is, changing of time zones for countries is something that happened a lot. So watch out. Next one, there's this day. Well, Danny is a great full-stack developer, and after he has done all the code in Python, of course, because it's the best language for the backend part. So he's going to write a UI on JavaScript. And what better format than JSON to send it out? But guess what? JSON doesn't have a way to represent date times like natively. So you try to do JSON dumps, and you get these beautiful type errors. Guess what? JSON born doesn't like date times. So what can you do? You need to serialize it in some way. There are 3 ways to do it, 3 normal ways to do it. The first is you can just convert it into a string. Please use a standard. I'm tired of seeing like dates. That is, here in the US, you do month, day, year, which I find crazy. In Europe, we do day, month, year, and in Japan, they do year, month, day. So don't assume that your standard is the great one. Just use ISO 8601. It has a way to serialize all kind of time-related objects. You might also want to use just an integer, and that's what, for example, the Unix time does. So the idea is you just choose an epoch, which is just a moment in the history. For Unix, it's the 1st of January of 1970 in GMT, sorry, in UTC +0. And you just start to count the number of seconds since that point. You have to be aware, well, you have to choose whether you count or not leap seconds. And the simplest way is you can just serialize it to an integer and assume this is going to be Unix time. There are all the epoch-based times, like, for example, the GPS one. And last one, if you want to go more complex, this doesn't work for the UI use cases, but if you're serializing, for example, your datetime into a databases, something you can do is you can just serialize your datetime objects into JSON objects. So you have like an object inside the JSON. And then you can add some hooks to the JSON loads to be able to decode it. No more issues for Danny, right? Now he knows how to serialize times, how to send it to the UI, and now he has a really nice and beautiful UI that works with time. By the way, if your application uses JSON a lot, watch out for Python, because by default, JSON can produce invalid JSON that you won't be able to read on the UI. Next example, time arithmetic. So George, well, how many people here have seen Lost, the TV show? How many people liked the final chapter? Cool, I don't feel alone. It was horrible, right? Such a great TV show, and the worst episode to end it. Okay. So George works in this situation where he had to type the numbers every day. So he found out, hey, let's just write a really small Python program to do it. And all he's doing is he's just adding 24 hours. Well, he's just adding a day, and every single day the Python script is going to type the numbers. Guess what? The island goes kaput. And the problem is that adding a day can mean many different things. Because we have DST. For example, here we can see that you get the daytime with Madrid time zone, and you add the day, and that added 25 hours. So, if you have to do time arithmetics, that's a really, really, really tricky problem. So think twice about it, and figure out whether you are adding wall time or you're adding like absolute time. PyTset by default adds absolute time, while dateutil works with wall time, which is much nicer. If you are using dateutil and you want to add absolute time, just work in UTC, because if you are using timestamps, you should be using UTC. No more issues for George. Now he can automate it, though the island has blown up. I don't know what it's going to do now, but well. So reviewing the tips, always use time zones. Use dateutil or PyTset to handle time zones. Please don't do your own time zone handling. I've seen this so many times, and it's always wrong. Okay, even your heroes have made mistakes handling the time zones on their own. Always use UTC if you're working with time zones. Remember that the day is not always made of 24 hours. Keep your time zone database up to date, and always, always, always test your code against situations like DST changes. Some libraries worth mentioning. You have PyTset, which was recommended until 3.6. Dateutil, we have Paul here. You can ask him any question. Recommended from 3.6. Arrow and Pendulum are just drop-in replacement for datetime that give you by default time zones and things like that. You have AstroPy, which is really handy if you need to work with leap seconds. You might need a specific hardware for that, but just to give you at least a pointer on how to handle it. And freeze-count, which is your lifesaver because it allows you to write really easily write tests for time-related problems. Links and references. So you have the Pluto's Cave, PEP 495. We finally can do proper datetime in Python. It's a really nice reading. NTP, if you wonder how time actually works in your computer, because we don't have atomic clocks in our laptops, as you can imagine. Doesn't smell like session. Google's maritime, what happens with the leap second, how it's handled by our computers. The standard way of representing strings, that's a really nice blog post about how to handle daytimes. If you want to go crazy about time, okay, there is a new level of it, which is the fact that time is relative. I don't know if you heard about the theory of relativity. And this probably doesn't impact you. It's a really good reading yet. But if you have to work, for example, with GPSs, you might realize that the way the GPS need to measure the time is different than the way we measure it in the Earth, because the time doesn't go at the same pace if you don't have the same gravity, or if you don't go at the same speed. If you have seen Interstellar, you might know about what I'm speaking about. So don't worry, this is not the place to work. This is not going to be a talk about, whoa, come to work with us, blah, blah, blah. I hate those talks. I really think the organization should do something about it. I've seen all talks are like, yeah, this is a recruited talk. So I'm just going to say, I'm working in the organization of PyCon Spain, really good food. It's an amazing place. Please come. And we have for companies, 25% of unemployment at the moment. It's great for recruiting. So that's it. By the way, I work for Bloomberg. If you're looking for a job, okay, we are recruiting in London for news automation, San Francisco for Python infrastructure, and we have also many openings in New York. So that's all. If you have any questions. Please be sure to use the mic. Cool. More questions? OK, we have one question.
On? Cool. Thanks. I want to ask about user-friendliness. So there are about 400 geopolitical time zones like America, Los Angeles, Europe, London, 24, well, mod 24 offsets. Users don't care about the geopolitical ones, but we need to know them. So what, you have a drop-down. How do you bridge the gap between what a user cares about and what you need to get it right?
Yeah. So to be sure, I understand the question. The problem is there are way too many time zones, and when you have a drop-down, you cannot just put all of them because it's gonna, it's gonna. So what I've been doing so far is, because there are so many, I'm just using an autocomplete. And because usually the time zones will have both, if you are using the old zone database, which is what's shipped by default with, for example, PyTZ or Dateutil, you have both the country and the city usually. So you can just start to type, and it will appear the one you want. Also, something interesting, there are some cities that have 2 entries in the time zone. Like Istanbul, you have Asia, Istanbul, and Europe, Istanbul. So cool.
So when you're trying to schedule like an appointment with someone else like on a calendar, and they're in different time zones and they may change, how do you resolve the fact that maybe it was 8 hours difference, we scheduled a certain time, but then let's say London transitions relative to like New York. So what happens in that case? Yeah,
so sadly there is no good solution for that. So the problem here, just to give some context, is you schedule a meeting, and the meeting happens in 2 different countries at the same time. So the meeting happens in, let's say, San Francisco and London. And the problem is because they changed to summertime at different time, so it's like 1 week of difference, you have to choose which time zone is going to be your reference one, because one of the sides have to shift the hours. And there's no good solution for that. So, sorry.
I do lat long to time zone kind of problems. And I'm wondering, how do you handle out in the ocean when there is no real...
The ocean? Like,
Yeah,
what do you mean?
I'm on a ship in the middle of the ocean. I have a lat long that's in the middle of nowhere.
So you have to decide what's your time zone. The things like for all countries, you'll have your country by law will decide which one do you have to use. But again, it depends on use case. I'm not sure what happens when you're in the middle of the water. Absolutely no clue. Thanks. I'll check it out. Really, really good point. I guess, just use UTC.
Do you have any tips and suggestions on the type of databases, either open source or commercial, that deal with time zones elegantly?
Sorry, can you repeat the question?
The time zone, like any tips or suggestions on the database that deals with time zones elegantly?
Sorry, on the what?
Time zones.
Okay.
Yeah.
So you mean which libraries to use, or?
I guess internally we're trying to.
Databases.
Databases.
Oh yeah. So just use the Olson database. That's is the most standard one. You just have to be sure that you update the one that you have deployed to your computer. This is usually deployed to your host. So you just get it. If you just do pip install pytset, it comes with the whole Olson database. And they keep it up to date whenever a country changes it. But be careful. Some countries might decide to change time zone in, tomorrow we're changing it. So if you have really time-sensitive applications, watch out for these kind of events. Like Turkey announced it like 1 week earlier or something like that, which was a huge thing in our company.
What are the extra super secret slides that you have?
Yeah, so I have, what's the difference between UTC and GMT? PyTset versus dateutil, and how does time work in your computer? How does NTP work? Really interesting. And then smear time, and this is how Google smear time works, which is also really similar to how Bloomberg smear time works. I don't know if we have time. Where's the? Sorry? Oh, come on, you have to say, yeah, don't you have to leave. Okay, so let's speak. Okay, so I think let's speak about smear time. So, the issue with the leap second is that, for example, Python won't expose you in the data model the leap second. So, and most of the languages, actually, like Unix time doesn't expose it at all. So your computer doesn't get the concept of the leap second. So what most companies do is that they just smear the time. They just smear the second across the time around it. This looks like a great idea, but if, for example, you work, like I work with news automation, where you might need to publish a news at a specific time, if you publish it a little bit earlier or a bit later, you might get fined. That can be an issue. So here, what you can see is tie, which is like we take it here as a reference because it counts the leap second. You have the unsmear UTC. You should be able to see that there is a point where you have up to 60 seconds. Okay, the last one should be 59. But UTC defines this leap second, which allows you to go from 59 to 60, and then you go back to 1. And back to 0, sorry. And then you have the smear time, which is what you're going to see in your computer. So what's actually happening is that the time in your computer is not going to be the same time in your clock for a short period of time. If you want, we can do UTC versus GMT, because sometime we just, okay, 2 more minutes? Cool. So UTC on GMT. So GMT is just the mean time, okay.
Can I ask a question about smeared time? How long of a time is the 1 second smeared? Over the whole year, over a day, over an hour?
That's up to how you configure your NTP servers. So, for example, is this working? Yeah. For example, here you can see that it's smeared from 14 to 38. So, yeah, and in Bloomberg, I think it was for 2 hours or something like that. It's up to the person who's configuring the NTP, however they configure it. That's your choice. Like, it's totally your choice. Cool. Thank you very much.